Now we're going to engage in some heavy-duty graphing. I'll just call it heavy graphing. I want to take everything that I've been talking about, all that stuff about max and mins, increasing and decreasing and inflection and everything, and apply that to one problem. And then I'll do several examples of different kinds of functions that we'll be dealing with. So let me start off with the easiest you can get, I suppose, for any of these types of functions is a polynomial. So let me get f of x equals 9x cubed plus 6x squared minus 6x plus 1. And I'm going to do everything by hand. That is, when you take an exam with me, you're going to have to do everything by hand. That includes finding the zeros and everything like that. You can still use your calculator to help you. It's just, if I ask you to get the exact ones, you got to remember some of the things that you used to use to find these values. I don't see any way, like if I try to group things, I don't see a good factoring that I can do to find any zeros. Let's start with the intercepts. I can't believe I did that. Let's start with the intercepts, and I'll start with the x-intercepts. And these involve setting the function equal to 0. And you spent a lot of time in college algebra and pre-calculus coming up with ways of getting these if you could. Now, I'm not going to give you one that you have no chance of getting the zeros. You'll be able to do it using some method that you've had in the past. So for like this thing here, you might remember one place to start this is to look at things of the nature P over Q. There was even a P over Q theorem that allows you to find rational zeros, if they have any. If there are any rational zeros in here, they have to be one of the following. The numerators have to divide into 1 evenly, so they have no choice but to be 1. The denominators have to divide evenly into 9. Your possibilities there are 1, 3, and 9. I put the plus and minus out here because plus and minus is always a possibility. So for example, we'd have 1, then I'd have 1/3, then I'd have 1/9. So in total, I have a total of 6 zeros here, possible zeros. What I like to do before I even try, you can plug all of these in, and hopefully you'll get one of these to work, or more than one to work. I think what I'll do is I'm going to throw it on a calculator real quick to limit this list to a smaller collection of numbers. So let's go ahead and put it in here. 9x cubed, don't forget to come on down from there, plus 6x squared minus 6x plus 1. And as usual, I'll do zoom 6 just to get a starter graph. It's hard to tell here. That could be -1. I'm going to zoom in, I think. Zoom. I'm going to do a Z box. And what you do is you start it, find it somewhere. Let me get my Y values. Come back here. Basically what you do is that starts the upper left corner of a box. I'll move over, hit enter to do that. Enter. Now this one is clearly not possible because if I trace, let me go and trace and see if I can get to, that's less than -1. There it is. So it's a little bit less than -1. So it can't, none of these can be the -0. So what about over there? Let me now trace that way. About 0.28. It starts at 0.32. The only thing that's even close is 1/3. 1/9 would be 0.11111, but this is 0.3333. So the thing that I'm going to try is 1/3. And I'll remind you of something really cool that you probably, I don't know if you forgot about it, but it's called synthetic division. If I think that 1/3 is a 0, I can test it using synthetic division. And all you do is copy the coefficients down. You'll probably remember this as soon as I start it. First thing you do is take this number 9, the leading coefficient, and you drop it down. Then you take 9 times 1/3, that equals 3, and you place it under the 6. Now you add. Do the same thing again. 9 times 1/3 gives you 3 again. I add, I get -3 there. Then -3 times 1/3 is -1. So in fact, 1/3 is a 0. More so, this actually tells you how it factors. F of x factors this way. F of x equals x minus 1/3 times 9x squared plus 9x minus 3. And so 1/3 is a 0. And I can even clean this up a little bit. Check this out. I'm going to rewrite this as 3x minus 1 times 3x squared plus 3x minus 1. What I did is I took a 3, I factored out a 3 from the second factor and sucked it into the first factor. So 1/3 is one of the zeros. To get the rest of the intercepts, I need to find the zeros of that. So I'll set that equal to 0. Once I get down to a quadratic, I'm pretty satisfied with using the quadratic formula to do it. It's not that big of a deal. X equals, remember, negative the b, so negative b plus and minus. Then you have b squared minus 4 times a times c all over 2 times a. Now inside of here I have 9 plus 12, so that's 21, all over 6. There's really no way of simplifying that, because you can't really take anything out of this radical 21. So I've got my x-intercepts. They are 1/3, 0, and -3 plus and minus radical 21 all over 6, 0. The y-intercept is very easy. So f of 0, what was the last coefficient? F of 0 equals 1. So the y-intercept is 0, 1. So I've got my x-intercepts, y-intercepts. By the way, I didn't hit this off in the first place, but I should have. The domain of any polynomial is -infinity to infinity. The range, well, since it's a third-degree polynomial, you have two possible ways that it can look. It can look something like this, or it could have two local extrema. So no local extrema or two of them. Those are your only options. And plus it has to orient this way because the first coefficient is positive. So it's got to be one of these two things. Either way, as it goes, it stretches down from -infinity all the way up to +infinity. So no matter what, on any odd degree polynomial, the range will always be -infinity to infinity. So I got this the typical things that you would have done in college algebra. Now we get to the calculus stuff. I would like to know if it does this or this, and the only way I'm going to find that out is by taking the derivative. I think I already did, actually I already know it looks like this because I did sneak a peek at the graph, didn't I? Yep, it goes up, then down, then up. Well, let's go through the steps. I want to get this exact. These numbers, the exact version of these numbers I could not have gotten on the calculator. This, you might have been able to do it if you recognize that 0.3 repeating is the same thing. So let's take the derivative, f prime of x. I'll put f of x here just to remind myself. It was 9x cubed plus 6x squared minus 6x plus 1. F prime then is 27x squared plus 12x minus 6, and that equals 0. Or you set it equal to 0. I think it probably wouldn't be a bad idea to divide everything by 3. Let me do that. So I get 9x squared plus 4x minus 2 equals 0. And once again, I'll use the quadratic formula. So x will equal negative b plus and minus b squared minus 4 times a times c all over 2 times a. So I'll have negative 4 plus and minus. Let's see what we got inside of here. This will be 16 plus 72, so that'll be 88. And that'll be over 18. Not a lot of simplifying can happen here. I can factor out, the best I can do here is factor out a 4. So I'll get negative 4 plus and minus 2 radical 22 over 18. And if I divide 2 into everything, I get negative 2 plus and minus the square root of 22 over 9. So to see if I have max and mins, I'll put this stuff on a number line. And obviously the negative 1 is to the left of the positive 1. A lot of these things you can do in your head. If I'm going to do test numbers, for instance, I know this is negative and this is positive. So I'll test 0, which was easy. If you plug in 0 into the derivative, f prime of 0 will equal negative 6. Negative there, so it's going down. It's decreasing. Now to the left, if you allow me, negative 22 is not quite as negative as negative 5. So this isn't even negative 1. It's a little bit bigger than negative 1. So as a test, I'm going to throw in negative 1. If I plug in negative 1, I'll get 27 minus 12 will be 15 minus 6 will be 9. That's positive. So we're increasing. So this location right here, I'll have a local max. And we already know what's going to happen, but because I peeked at the graph. Over here, like I said, this won't even be as high as positive 1, so I'll plug in 1. If I plug 1 in for x, I'll get 27 plus 12 will be 39, minus 6 will be 33. That's positive. And so it's increasing again. So I probably was a little bit, I should have put the plus here, increasing. So I have, at this location, I have a local min. Now, what is the local max and the local min? The local max will equal negative 2 minus the square root of 22 over 9, comma, and then I have to plug it into the original function. Now, a lot of my students right here just plumb give up the attempt of doing it. I think they're okay with actually losing credit because plugging this in is so arduous they don't even want to try it. Well, I have done a video already, which if you take your time, this isn't so bad to do. I typically don't do it by hand either, though. What I do is I take and plug in, let me see here, well, I'll do the numbers. I'll show you how it works on my calculator. If your calculator has a CAS, a computer algebra system, then you'll be able to do this too. So -2 minus, and I'll do shift the square root of 22, and in the denominator I'll put a 9, and I'm allowed to store it into a variable. Backspace. I need to get out of there first, then store. But what I'll do is I'll use the letter P. If I enter, that's the way my calculator tells me that it's stored in there. Then I can simply go and write the expression for this polynomial. The only thing with my calculator, the HPs, is I have to put the symbols in there. The multiplication symbols. And that was +1. And what it does, it will give me this big long expression, but then I'll hit simplify. See that? So this is 205 plus 44 radical 22 over 81. And for the local min, I'll have the other one, -2 plus the square root of 22 over 9, comma. And I'll do the same kind of a game. I'll come back here to the calculator. But what I'll do is I will take that P, and it allows me to copy it. And then what I'll do is change this to a plus. Enter. And then I can go back up here and grab this expression and copy it, and then hit enter. And once again, simplify to get my answer. This shouldn't surprise you. This part right here, this is like the conjugate of the other one, and that shouldn't surprise you because they were zeros of a quadratic. So I have 205 minus 44 radical 22 all over 81. Now, where is it increasing and where is it decreasing? It is increasing from -infinity to this number here. Union, and then it's increasing from this x value to infinity. And it's decreasing on this interval in between. So there you go. This is all the stuff the first derivative can tell me about the thing. It tells me where the max and mins are, increasing and decreasing. Notice that neither of these is an absolute max or min because the function does stretch from -infinity to infinity. Now then, that we have that, the next thing to attack are the points of inflection and concavity. So let me take the second derivative. And I'll go back and find my first derivative, which was 27x squared plus 12x minus 6. So my derivative is 54x plus, and I have to peek again, I didn't remember in that short amount of time, 54x plus 12. and you'll set that equal to 0. And as before, I'll divide everything. I think 6 goes into everything here. 6, 6. So I have 9x plus 2 equals 0. And so x equals negative 2 over 9. And I'll do a sign chart for f double prime with just that number on it. I'll mark off negative 2/9. So for my test value, I'll take it easy here, negative 1 and 0. If you throw in negative 1, you'll have negative 54 plus 12. It'll be negative, concave down. Plug in 0, you'll get 0 plus 12, which is positive, concave up. So right here is a point of inflection because it changes concavity from down to up. What is the y value of that point? So to get that, so the point of inflection equals negative 2/9. And I want to plug that into the original function because you want the y value. Well, I'm going to do the same game I did before and not do much in the way of by hand. And I will do, come back here with my p. I'll copy it. Come up here, and I'll simply take that stuff out. Hit enter. There it goes. Take this guy, copy it, enter, and it tells me 205 over 81. So I was able to use a calculator to help me get exact answers. And then we are concave up on negative 2/9 to infinity, and concave down on negative infinity to negative 2/9. So I have everything that I could want. I have points of inflection, concave up, concave down, increasing, decreasing, local max, local mins. The last thing I want to do is draw a graph of it. What I'll do is let me draw just a rough sketch of the thing before I bring in a computer generated one. And I had this here, which is negative 2. What was that? 0. Let's go back all the way to the top. There it is. Negative 3 minus the square root of 21 over 6. And then we had one at negative 3 plus the square root of 21 over 6. And then I had 1/3. Let me get a handle on how big this is so I know where 1/3 fits in there. Negative 3 plus the square root of 21. I'll hit enter, and then I'll divide by 6. That's a 0.26, so 1/3 would actually be over here a little bit. So let me see if I can fix this up. What I'll do here then, I'll do negative 3 plus the square root of 21 over 6. I'll do a little arrow thing. And then not much farther than that, I'll have a 1/3. And it's going to come here and do this kind of stuff. I know it had a y-intercept of 0, 1, so let me put that in there. And it had a max in here, and then it comes down. Kind of hard to get this. It has to come down through these points and go like that. So what it does in between here, I've got a kind of an ugly looking thing going on my graph. Let me perhaps take this thing out. It looks like it probably dips less. So let me see if I can do that. I'll tell you what, let's connect to this like so, and then I have something like this. It's really not much under there. But then this part's all messed up. It really, because there was a point of inflection at -2, was it -2/9? Yeah, -2/9. So maybe my graph's not as terrible as I thought. -2/9. There was a point of inflection where it's going from concave down to concave up. And the y value was 205/81, so I would put -2/9, 205/81. So that's a POI. Then we had local max and mins. What was my local max and min? The local max was -2 minus radical 22/9. And the y value, if I'm not mistaken, was 44 plus, I'm not remembering, 205 plus 44 radical 22. Over 81. And then the local minimum, if I put it down in here, see if I can snake some arrow into there. I should probably not put it there. Let me take that out. And should probably do this instead. Like this. So we had -2 plus radical 22/9, comma, 205 minus 44 radical 22/81. And the point of inflection I have all my zeros. So there is a rough sketch of the graph. Now I'm going to treat this like an English writing assignment. To me, this is a rough draft. I am now going to use the computer to draw a beautiful picture, and then I'll label it with all of these numbers. All right, what I have here is the graph produced by the computer. And let me go ahead and label the points I knew. This one right here, the x value for that intercept, back up to my -3 minus the square root of 21/6. I should have picked a better spot to do that in. My local maximum up here was -2 minus the square root of 22 all over 9, comma, 205 plus 44 radical 22/81. I had a point of inflection, -2/9, 205/81. 205/81. I guess that's about 2.5, so I know where to locate it at, somewhere around 2.5 in here. So -1/9 is 1/3, -2/9, so 1/3 of this, but times 2, so 2/3 of that. So somewhere in here, I'll have my point of inflection. That'll be -2/9, comma, 205/81. Here, there's a lot of stuff going on down here. I have like mins and a min in there and 2 zeros in there, and I can't really see all that stuff. Now what I might do is I might take a circle this, and I'm going to bring in a super blown up portion to that piece of graph. Alright, I've brought in that piece, zoomed, blew it up. There's the 1/3, of course. This here, that would be -3 plus the square root of 21/6. And then this local minimum here was, it's up here, -2 plus radical 22/9. and I believe that was, I don't even want to go 205 minus 44. So I have everything that you could possibly need to know based on a graph, a beautiful looking graph. It's too hard to see that in here, so I blew it up. I should probably just say this is, maybe put a big circle around all this so I know what that piece is doing. Gave myself more room by zooming into it like that. So this is a very nice thing. This is what I'm expecting. Just a picture, a graph. A lot of students will just draw the picture because their calculator can do it, and then just submit that and they get 0 points. And so that's not going to do anything. You actually have to do some work on these things. The reason why I have you do this exact is because calculators can do so much for you. I need you to do these exact so that you show me that you can do the calculus that is involved. All right, what I'm going to do next, I'm going to do several different types of functions and try to do this kind of analysis with them so that you start to get a good feel for this kind of stuff. These are time-consuming problems, and with some of the horrible-looking numbers that are involved, that can cause a lot of frustration as well.